Well, hi everybody. Hopefully you're doing okay out there. We're going to try to run lab remotely for at least the next few weeks, if not the rest of the semester. We'll see how it goes. We're going to tackle Lab 5A today. So I've broken into Niels to try to get some experimental data for you guys, set up the apparatus. We'll talk a little bit of physics first. What's going on in Lab 5A is the study of collisions and the conservation of momentum. So you have or will shortly be learning about the conservation of momentum. Just a quick refresher in case you need it. Essentially, if we take the sum of all the momentums of two particles or two objects before a collision, we can set that equal to the sum of the momentums of all the objects after the collision. Further, we can break this into x or y components. We can add up all the x components of momentum and set them equal to all the x components initially and finally. We could do this with y as well. And so I'm showing that to you right down here. As you can see over here, the experiment is going to involve two pucks that are colliding on what's essentially an air hockey table. Each puck has an initial x and y momentum to it. If we add up the x momentums of both pucks, they should be equal to the x momentums at the end, before momentum and after momentum in the x direction. We should also be able to do that with the y direction. If we add up the y direction momentum of both pucks initially, it should be equal to the y direction momentum finally. So keep this in mind as we're building our formulas in Microsoft Excel, because essentially that's what we're doing. We created a template for you this week to make it a little simpler to deal with, but you'll still have to do some Excel formulation on your own. And what you're essentially doing is comparing the initial and final momentum, albeit in the x and y direction. Of course, we would expect that they would be equal. We would expect that there would be no change in x momentum and no change in y momentum when we compare the before and the after results. All right, let's move on to the actual data gathering process here. I've taken you over to the actual air table. I'm just going to rotate this down for just a second. You can see that we actually have about a 4 foot by 4 foot square air hockey table. You can see I have two pucks right here, which will start levitating as soon as I turn on the big shot vac right next to me. You might also recognize that calibration stick from the second lab that we did. So again, because we're using the video analysis here in Tracker software, we're going to need to tell the computer what 1 meter is. I have handled that portion of it for you since you're not in the lab and can't do that. We also have mounted way up here in the ceiling, you can see this camera. I've preset the frame rate for 240 frames per second. I have already incorporated that into the Tracker software. Essentially, all that's left to do is fire up the air hockey table and take the data. Okay, so by now each group in the class would have gathered their data and would have come back to their labs, to their respective lab stations. We would have uploaded those videos from the camera across the lab onto the network space. You would have downloaded them and you would have loaded them into the Tracker software. So I'm not going to pretend that you're going to be able to see very much on here, but essentially we would download that video here and you would use the Tracker software to select point masses. The Tracker software would then follow each mass, much as it followed the projectile in Lab 2. It analyzes its motion, and after you program in the calibration stick, the computer can then determine the distance that each puck moves in each time frame, in this case, 1/240th of a second. We could then export that data into Microsoft Excel and run with it. So once again, as I said earlier, we're going to provide to you guys a template for this week's lab. It's called Lab 5A Template Online Learning Version. That video that we're using for this analysis, the template, as well as the lab report forms are all going to be included in the Blackboard assignment. So these will all be something you'll submit on Blackboard. But this is where we turn it over to you guys. I went ahead and, as you can see here, loaded the data that we exported from Tracker into the template for you. Your job is to finish out the analysis here. We have provided you some pre-made formulas, some pre-programmed formulas that do calculate the initial X direction and Y direction momentum for each puck. We also show you how they are summed together. So essentially, it's your job to complete any of the yellow and green squares, either with values or by creating formulas to essentially complete the analysis here. At the end, you should be able to determine whether momentum was conserved by viewing the two z values respectively for either the system momentum in the X direction and the system momentum in the Y direction. Again, we're going to compare both the before and after results there. One other thing I included in this template is just a series, and this third tab down here, a series of screenshots. So again, you can see this in this file. This is something you can download, but a series of screenshots that can help you with the analysis portion. Again, as with any lab that we do, you're asked to write about any discrepancies from what you expected, including random error or systematic error that might be present in this experiment. So these are just some screenshots of the work that I did that can potentially help you answer those questions. Well, I realize this is going to be quite a bit different than some of our previous experiments. Yeah, I am expecting you guys to work alone on this instead of with a partner, since we really didn't gather the data in partners. And I'm also anticipating lots of questions, some difficulties, potentially some difficulties with the formulas or getting the results. Any questions regarding systematic error or random error, you can always reach out to me via email or any of the other ways that campus has provided for that. I could potentially be available during Mondays during this lab session online. Check your email for updates on that. Until then, good luck, best wishes, stay safe, and please contact me with any questions.